this video we're going to talk about percent yield. So to this point, we've been assuming that all of the reactions are going to completion. That is, that all of the limited reagents are consumed and are completely converted into products. And we're also assuming that we're actually able to collect all of the products. And in real circumstances, this is not true. There can be human error. Now, that can be accounted for, but sometimes there are experimental limitations where we're just not able to collect all of the products. There may be competing reactions, so there may be fundamental chemical reasons why not all of the reagents are converted into the products that we want. There's also the issue of equilibrium. Some reactions don't go to completion. That is, not all of the reagents are converted into products. We may have all of the reagents left over, and we have both reagents and products present at the same time. And so for a variety of reasons, it is not true that all of the reagents are always, or even most of the time, completely converted into products, and we're able to collect all of those. So what we have been calculating so far, when we calculate how much product we can make, is called the theoretical yield. This is defined as the amount of products that would be produced if the reaction went to completion. And the reason it's called theoretical yield, we've used this term before, that might not have made sense, is because we can only make that much on paper. When it comes to actual practice, we can never make that much. And so the actual yield is the amount of products that we actually collect. And so to represent this, we have what's called percent yield, and we calculate that by taking the actual yield, which I'm going to abbreviate AY, divide that by the theoretical yield, and multiply by 100. And so the percent yield should always be less than 100, because the theoretical yield is the most that we can make, and so we should never make more than that. If you're ever doing an experiment and you get a percent yield bigger than 100%, then you know something has gone wrong, and actually you want to go back and look and see what could be causing that problem, because that's not possible. And so I have two examples related to percent yield. In the first case, we're told that 25 grams of HCl is reacting with excess oxygen, and we're told that the reaction has a 79% yield, and so they want to know what mass of Cl2 is produced. So essentially what we need to do is do a stoichiometry problem like we've done already, and we'll use the 25 grams of HCl, see how much Cl2 we can make. That will be the theoretical yield, and then we'll use this percent yield equation with 79.5% yield to see how much Cl2 we will actually make. So they've already balanced our equation for us, and so I need to get this 25 grams of HCl into the mass of Cl2 that I could theoretically make. So I need the molar mass of HCl, so 35.45 plus 1.01, we get 36.46 grams of HCl is equal to 1 mole of HCl. For Cl2, 2 times 35.45 gives us 70.90 grams of Cl2 is 1 mole of Cl2. And then our stoichiometric ratio is 4 moles of HCl will give us 2 moles of Cl2. So these are the conversion factors I need. So now we can do the stoichiometry. Alright, and when we multiply and divide all of that out, I get 27.4 grams of Cl2. Now that's the theoretical yield, we want to know what mass of Cl2 is actually produced. So I'm going to use the percent yield equation. So we have that percent yield is the actual yield over the theoretical yield times 100. I'm looking for the actual yield. We could rearrange the equation first. With these, I usually think it's easy enough just to go ahead and plug in my numbers. So I'm going to put in 79.5 for the percent yield. The actual yield is what I'm looking for. I'll put in my theoretical yield times 100. So now we just need to solve for x. So first I'll divide both sides by 100. Convert that percentage into a decimal. And so I get an actual yield of 21.8 grams. All right, here's a second example. The first thing I notice is this equation is not balanced. So before I do anything else, let's make sure we get this balanced. I think I can do that by putting a 3 in front of the calcium. All right, and so in this problem, we've got 56.6 grams of calcium. It's reacting with 30.5 grams of nitrogen, and 62.8 grams of calcium nitride are collected. And they want to know what is the percent yield. So what they're telling me is this is the actual yield. So then I need to find the theoretical yield. If I have that, I can then calculate, I can divide those two, multiply by 100, and get the percent yield. But the other wrinkle here is they gave me the amount of both the calcium and the nitrogen, right? So I don't know what the limiting reagent is because they didn't tell me. So the first thing I need to do is essentially do a limiting reagent problem, right? Whichever reagent gives me the least amount of product, that will be the theoretical yield. So let's go ahead and do that. And I think what I'm going to do is collect all of the molar masses I'm going to need right up front. Right, so the molar mass of calcium, I can just look that up. So 1 mole of calcium, 40.08 grams of calcium. N2, 2 times 14.01, so 1 mole of N2 is 28.02. And then calcium nitride, I do not know off the top of my head, so I'll do 3 times 40.08. 2 times 14.01. When I do that, I get 148.26, so and then my molar ratios, I'll write those off to the right here. 3 moles calcium, 1 mole calcium nitride, 1 mole of N2, 1 mole of calcium nitride. Alright, so now I'm ready to do my 2 stoichiometry steps, right? One for the calcium, one for the nitrogen. So if we do calcium first, first divide by the molar mass to get it to the moles of calcium. Then my molar ratio. Alright, and when I multiply all of that out, I get Alright, now we need to do the same thing for the nitrogen. And when I multiply that out, I get 161 grams of calcium nitride. Right, so clearly this is the lower mass, so that is my theoretical yield. And then we have our actual yield. So the percent yield then is the actual yield divided by the theoretical yield times 100. And when I do that to three significant figures, I get 90.0%. So that would be the theoretical yield of this reaction.